Example 10.1. A boy flies a kite with the string at 30 degrees to the horizontal. The tension in the string is 4.5 newtons. How much work does the string do on the boy if the boy stands still, walks a horizontal distance of 11 meters away from the kite, and then walks a horizontal distance 11 meters towards the kite? Now, what's important about this example? What's important about this example here is that we want to set up a picture. Okay? We want a picture and we want to start drawing the situation to make sure, because once you got the picture, then everything will then follow the exact same process with Newton's laws like we've talked about. So here we go. So the first thing that I'm going to do here is that I'm going to look at what's going on. So if I look at A, what we're seeing here is that the boy is stationary. So if the boy is stationary, then that means here that there's no displacement occurring, and therefore no work is done. So what does that mean if there's no work that's done? So let's think about the boy with the kite. So you could imagine that I have a situation that's going to go something like this. Here's our boy on the ground. And when you look at the boy here, you could imagine that he's holding the kite off in some direction here. And you could imagine that I have a kite that looks something like this. And so then, of course, we have this sort of a tail for the kite here. And that kite is flowing, moving in the air. So picture-wise, what am I actually seeing here? So if I look at the system, what I'm going to say here is that my system here has to be the boy. So if the system is the boy, what is acting on this boy here? So according to this, I have a net force acting on this. So then I'm going to come in here and I'm going to say that there is a force. In this case, I'm going to say that there's a tension. So if there is a tension here, we then say here is that from the work energy theorem, then if there's no displacement, then we're going to say that the net work, we say no displacement. So therefore, that work has to be equal to 0. And if that work is equal to 0, we can clearly see here that there is work being done on the kite here in some sense here. So then what we would say here, that if I focus on the kite here, we would then say here that then if I look at the net work here, that net work is going to be this tension force. And then I have to look at this displacement. And so let me be careful. What I said is, what is the work on the string or the tension done on the boy? So I said network, but this, I really mean the, oh gosh, my language is bad. I'm going to erase this again. Sorry about that. What I got to say here is that then the work of the tension, that has to be the tension times the displacement. But in this situation, what we're seeing here is that the displacement must be equal to 0. And so therefore, that means that there's no work done by the tension of the string. But if I look at the system here, what does that mean? Well, that means that in order for this boy to have no change in energy, then that means that there has to be no work done by the tension. So in other words, the tension does not change the energy of the system. So if I'm looking at this thing as a bar diagram, then I'm going to come in and I'm going to just say, okay, this is my energy of the boy, and it has this amount of energy. And what I'm finding here is that the work of the tension here is 0. And as a consequence, the energy of the boy did not change because there was no work done. So in that sense, it's straight up like that. But that's different if now it says that he walks, towards, away from the kite. So if you're now walking away from the kite, so now the boy is walking away from the kite, then what actually happens here? So now what I'm seeing here is that I have my kite again. And so if I'm looking at my string here, you could then imagine that now I have the boy that's now walking like this here. So what I'm seeing here is that, again, if I look at this thing, I look at my system here, and again, my system is my boy, and you can see here that I definitely have a tension force, and in this situation, I have a displacement that actually goes to the right. So then if I look at a free body diagram, I could then show that in this situation, I do have a force that moves in this direction, which then means I can break this into components like this. And in this situation, we're saying here is that the angle here is 30 degrees between the horizontal direction. So now, if this is my coordinate system, and my displacement is in this direction here, then you can see that there are two workings that are occurring. So there are two workings. One there's the work of the tension in the x direction. And what we're seeing here is that the tension in the x direction, we clearly see that they are in opposite directions. So the tension in the x goes like that. The tension in the, the displacement goes like this here. So now I'm going to change how I write this to try to be a little bit more clear. So I'm going to say that the tension and the x goes like this. My displacement goes like this. So therefore, the work due to the tension in the x direction must be negative times the displacement, which in this case then becomes minus the tension cosine of 30 times my displacement like this. So if I compute this number, then what I'm seeing here is that I'm going to get a number that then reads what? I'm going to get a tension of 4.5 joules, cosine of 30, and in this situation, the distance that the kite moves here is 11 meters. So if I multiply this by 11 meters, I'm then going to get minus 43 joules for the tension in the x direction. So I'm going to get scrunched up over here. So I'm just going to move this right over here so that I don't scrunch everything up. So in this case, what actually happens? There's energy being taken out of the system. So then what happens here is that the boy starts off at a higher energy state. And there is negative work done by the tension. In the x direction. As a consequence, the overall energy of the system has decreased by this amount. Do we know anything about E1 or E2? No. This is a meaningless statement. E1 by itself is meaningless. E2 by itself is meaningless. What is meaningful is the change in energy. Only the change in energy is meaningful. Only the change in energy. And this is the only thing that matters. Which is crazy. Because what happens a lot of times? People will say, I'm low in energy. Meaningless. I have too much energy. Meaningless. This is meaningful. You can only talk about changes in energy. Let me just, just as an example here, the way to think about it would be something like that. Now, if I look at part C here, what happens now is that the boy, instead of walking away, is walking towards the kite. So now the boy walks towards the kite. So in essence, the wind is now moving in the same way as the boy. So when I'm looking at this thing, now I have a picture that's going to look something like this here. So when I'm looking at my kite here, what you're seeing here is that now the boy is moving in this direction. So what you're seeing here is that now the displacement is along this direction. And now the tension is going in that direction like that here. So very analogous to what we showed over here. By the way, I said that there was 2 workings, and I didn't do the second working. What was the other working? You could see here is that Ty is now perpendicular to the displacement, and therefore that tells me that the work of Ty, which will be Ty times the displacement, but in this situation, the displacement is 0, so therefore that work is 0. So if I follow the same process as up here, I'm going to focus on a free body diagram. So if I look at the exact same free body diagram, again, we have the situation where I still have my tension that's broken down into Tx and to Ty, but now the displacement has changed directions. And because it's changed directions, you can see here that now there is positive work by the work of Tx. Why is it positive? Because now I see that Tx and the displacement are in the same direction. So when I look at this work here, we could then say that the work of T of x is now going to be positive Tx times the displacement. And so then this will then be positive T cosine of 30 times the displacement, but they have the exact same numbers. So then this would then be positive 43 joules. So in other words, here's what I find here. This work is positive, so that means here, if I look at a bar diagram, the boy starts off with some arbitrary energy, E1, and now we are doing positive work. And as a consequence, the energy of the system has increased. And then the question is, what is meaningful? This is meaningless. This is meaningless. What is meaningful? What is meaningful is above E1. It's this guy that's meaningful. And it is this guy that we calculated. So when we look at energies, we talk about the change in energy, not anything else here.